Yeah, that's a very challenging problem. That's that second for anybody who's at remote, so I started streaming already, I think. We were just talking about the change problem from last class. Do I have it up here? I don't think I do. Anyways, we were talking about that, and that second one, which was try and find all the different ways that you could give the change back, every combination that's a challenging problem. That's the type of thing that would be like you might find at an interview if the place is fond of like programming puzzles for a tech interview, is they may ask something like that, because there's different approaches of coding, and one that is a common way to try and solve that is this sort of really, I mean, I wouldn't say it's super advanced, but more advanced than standard stuff, which is known as like dynamic programming, which is the concept of the program basically feeding back into itself to be able to try and compute stuff. So, and there's that one's not that bad. There are some I think, I'm trying to think to it. Maybe I'll try and solve it, the more complex version. Haven't tried to solve it, but I think there are some naive ways to do it that may not be super efficient, but there might be some real efficient ways to accomplish it too. I'm not sure. The basic change one though, that one shouldn't be too bad. It's just combining some stuff a little bit more complex than what we've done.
Rather than trying to solve the full problem that $5, $1, and then just make it just a binary problem. Only say you had $1 and dime. Those are the only possible. So that it can cost some multiple to do. So you have something possible cents for $2. Try to figure out how to sell it. So that way you're still thinking about the same problem, but it's a much simpler.
Right. Yeah. Yeah, I could see two different ways to start tackling the change problem. I mean, there's a lot of ways to do it, right? But if you're trying to break it down, I could see two approaches to try. You could try and build up and say, okay, well, I only need to give them less than 5 cents worth of change. Let me solve that, which means I know that it's going to be pennies, right? So I don't have to solve anything more complex than pennies. And then you could say, okay, now I need to give them 5 cents of change, 5 cents worth of change. That's the price difference. And then you could go, okay, well, now I have to figure out how to solve 2 different cases, giving them a nickel versus giving them pennies. And then you could like just build up, piece by piece from there, like, oh, now 6 cents. Or you could start at a higher level, or you could start at the level where you're like, okay, well, I want to give them, 1 penny, a nickel, a dime, and then you could just start it at each one of those exact ratios or something. But there's really a lot of ways to sort of tackle that sort of problem. But again, as always, the best thing to do is break it down into the simplest case first. The one that maybe when you do it, you're like, this didn't get me anywhere near solving this problem. And then you add a tiny bit more and suddenly you go, oh, okay, well, I could easily add that portion in. It wasn't that bad. And then boom, you've built it all up, without realizing. So today we're sort of going to build on, I don't think I need this open actually. Let me try and close that. Goal today is to teach another just sort of tool that we're going to leverage more. going forward, and that is Yarn, or Jest, sorry, Yarn, Jest. So today I want to talk about Jest and sort of work through converting the tests that we wrote, or I wrote previously for the zip function that we had, into using Jest. And maybe I'll even take another example. I probably won't do the correct change one yet because I've only seen a couple people submit their code for it, so I don't want to necessarily post the answer to that yet. But I might do like one of our other ones that we've worked, like FizzBuzz or something, as another example of working through something with Jest. And then there'll still be time if people want to talk about computing correct change. We'll probably have time after this to do some more hands-on. But the goal here is to start pulling in more of this ecosystem, right? Pulling in more of these tools that are going to help us out, and the tools that we're going to be leveraging when we move into the next course, which is going to be the React course, because we're going to be building stuff with React. We're going to be using Jest as a testing layer on that, because Jest and React both come from the same company. They're both from Facebook. And so they work really well together. It's a lot nicer than trying to test stuff using a different framework for testing. Plus, Jest is just actually a really nice testing framework. It gives you a lot of the things that are maybe hard in other ones to tweak and configure. Like at my job, I've written a lot of tests with Jasmine and then Karma, and you don't need to worry about what all this means, but these are just layers to be able to do this. And Jest actually uses Jasmine, or at least used to use Jasmine under the covers. But it would take, you know, a couple days of just trying to get the configuration right to get that stuff to work. Not that the code is necessarily hard, but what's the right value in this config file, and go reading through all this documentation. Jest fixes a lot of that, so you don't struggle with it as much. So what we're gonna do is convert the tests that already exist for this zip into ones that use Jest, and along the way show a few other ecosystem bits about how this works and some of the benefits of doing something like this. I posted just a little bit before class. It'd probably be great, and you don't have to do it during class if you're going to get more out of just sitting and watching the first time. But I think it would be really good for you to follow along as sort of a hands-on. So maybe you sit and watch, and then you know, rewatch the video and follow along with the same steps so that you convert it. But I posted a link to the starting repository, which is just work that I've done for this sort of class, almost like my homework repository. And so if you pull that or fork that and then clone it locally, you should be able to follow along with the same sort of steps. And I didn't do anything else to the repository yet intentionally to make it so that this is, and I haven't, you know, pre-tested any of this, so that any issues that we encounter are going to be issues that I encounter live and aren't stuff that's already been solved by me. So it would be the same type of problem if you were trying to add this yourself. So the first thing I'll do is just step right over into the documentation, right? This is what I would do if I'm picking up any framework, starting to use anything. And it tells me how to install it, and we're not using Yarn, we're using NPM. So those are just two different package managers, ways to install stuff. So I'll follow along with the NPM instructions, which tells me to install save dev Jest. So I'm gonna come over here. Oops, sorry. I'm gonna come over here to my project that I have. And I'm just gonna open up console. And I'm a big fan of just opening the one right down here. Let's make sure it's in the right folder. It is, with that horrible green. Oh, it shows up a lot better up there than it does on my screen. And then I'm gonna run that command that they had. Oops, not the right one. In fact, I'm just gonna cut and paste it, I think. Save dev. And one thing that's interesting about save dev, and it doesn't actually matter that much on our specific project, but you will notice it if you're following along like this. Oh, and if you're in Cloud 9, there is a small chance that this will have the same problem that was noticed before with React, which is it might yell about the node version you're on. I hope not. If it does, let me know. If you're trying to follow along and you're on Cloud 9 and it doesn't install because of the node version, then that's going to mean I really have to prioritize resolving that. But now you'll see, oh my gosh, it installed a ton of packages, not just the one for Jest. It installed 547 packages just to install Jest. And if we go over and look at what's changed, this is what I was getting at that's interesting with when you did save dev instead of save normally, it doesn't add it to your dependencies list here. It adds it to a separate list of dependencies, which are called dev dependencies. That doesn't really matter that much when you're doing front-end development the way we are. It matters when you're doing back-end development, node stuff, potentially, because they bundle stuff up differently when it runs, but it's not a huge difference. And then if we took a look at the node modules folder, like we had before, let me see here, hold on, I'll need to refresh. Now I've got tons of packages installed in there and that's because the Jest testing framework uses a bunch of other packages. So.
I'm just following along, able to install Jest.
I found some more using that, but I didn't have like the same thing about failure.
Just
about no read data, no optional dependency, FS events.
okay, yeah. I don't think those shouldn't be issues. Unfortunately, you get those pretty much every install from NPM if it's a large thing. It's annoying. I don't know what the best option is to fix that. But I get it all the time at work too. It's just one of those frustrating things where you end up having to carefully read them, or unfortunately you start ignoring them and don't notice when a real problem crops up. Okay, so I'm gonna follow along with their stuff just as sort of a test of this to see what happens. So I'm gonna do pretty much exactly what they have, which, hey, I think I already have a sum, except, let me double check. You already have a sum in here. I have a math, which has add, subtract, and multiply, and it exports from there. All right, so I'm going to just use that and modify it a little bit. So then they put a test around it. They create a file, sum.test.js, and then put a test in there. So I'm going to just copy that, and it won't be sum.test.js. I think I'm using this sum in one of these. Well, I'll create a new one. Math.test.js. And since it's not actually sum here, I'm going to change the way that I do this, which is var math equals require .math.js, which is sort of the equivalent of this. And then here, I need to say math.add. And don't worry too much about this syntax right now. In fact, don't worry about it at all. We're going to cover that starting next week when I talk about some of the newer ES6 syntax. That's just a shorthand for a new way to write functions. They're known as arrow functions, but it doesn't make a big difference right now. It's just pretty common syntax and them being lazy. So then this is the interesting bit. This is part of the ecosystem I was talking about. They mentioned adding the following section to your package.json, which they've got this scripts section, and they add a call to test Jest in there. So this is what is one of the more interesting bits that we're going to do for this, which we should already have a package.json. I'm going to go ahead and add this script section. I'll just put it right at the very bottom below all my other dependency bits. And it even tells you a little bit about what's going on. Oh, I already have a script. Oh, see? So I'm going to kill this one. I have this one down here. It even, in my editor, it gives me a little hint, which is really nice. The script member is an object hash of script commands that are run at various times in the lifecycle of your package. You'll see in just a second what that means. But if we're following along, it says finally run, and again, we're using npm. So npm run test. I think we can actually just do npm test as well. And let's see what happens here. Because I have other files in this, it may do something beyond what theirs does, but we're going to find out. So if I do npm run test, it actually, what that did was it ran the Jest package that we installed in our repository here. And that Jest package by default looks for files with a certain name, in this case, .test.js, and then runs the tests that are declared in them. So it says, oh, I found one test suite. I passed the test. It took this long for me to run and find everything. So that did a lot of magic. Now, the reason we put this in the package.json and we invoked it with this scripts is if we just tried, because we installed Jest just in our project as a local thing, if we tried to run Jest right here, oh, shoot. Just a moment. Can I uninstall something globally? I think I have Jest installed globally. Let me try this. I can't remember the command. Uninstall global. All right. npm uninstall -g Jest. I just happen to have Jest installed globally before, I think. So.
Sorry, Jerry, I think, did you post the correct link for the live stream Slack? Because I think you posted it here.
Oh, let me. It must not, sorry. You're right. I am not live stream. I don't have the link for it. Thank you. Yes, so am I. Let me try that again. Maybe they have another way of getting to it. Because people are obviously watching it. They're even commenting on stuff. So maybe the link is not changing or something. I don't know. All right. So let's try that again. If anybody online needs me to rewind it all, let me know. We can go back through any steps. But what I was talking about right now is I've just followed the first few steps on this Jest page with getting started with Jest. I've run npm install, and because I had this math.js file already, instead of creating a new sum, I just used the math.js and changed this a little bit to work with it. And now I'm talking about why you use the scripts element in your package JSON to invoke stuff as opposed to anything else. And that's because, as I said, if you tried to run Jest normally, without that, even if you've installed it in your project, it's going to fail. It's going to tell you no such file or directory. But if I do that npm test, it runs Jest just fine. And that, again, goes back to this concept of Node having a relationship with the Node modules folder. If you run a script that's listed in this scripts using npm, it will actually look inside of this Node modules folder and load any executables that get put in this like bin. So if we go look, HIJ, you know, you've got a Jest, and so it's able to add Jest to your path and know that it exists and run it. Whereas if I tried to run it normally, I wouldn't be able to do that. If I was trying to do that without using the package JSON approach, I would have to do something more like node modules. Let me see here. Hold on. Let me node modules.bin/jest/ I think this. Oh, is that right? Let me see if that works. So then that I can run it that way, but that's a lot more cumbersome than being able to have it connected into your package JSON and call it directly. Now let's talk a little bit about what was different here in this test between, say, the tests that we'd already written, right? The first thing, yeah.
I got a warning that my package is
That it wasn't, what was that?
It wasn't like, it says, tell the package author to fix the package JSON file. Package JSON file must be actual JSON, not just JavaScript.
Okay, is that after you changed your, added the script bit?
What's that?
Is that after you modified the package JSON?
Yeah.
Okay. One thing to check for is to make sure that anything that you have as your keys are quoted. If you did that, is a possibility.
Go back to your
My package JSON? Yeah, no. Yeah, that's another common one is you need to make, this is actually just a list of things, so you have to have a comma in between each. Yeah, you're gonna need to make sure you have a comma at the end of your dev dependencies.
Yeah, that's the next one. I think that's why I was rejecting.
And also I deleted, there was another scripts section up above, I deleted it. So if you wanna do it easier, instead of what I did here,
Yeah, go back.
you know, when there's this other script section already, you could just replace the test line up there with this test jest. That would work just as well.
Or just delete that.
Yeah, one way or the other. Either of those works.
That's why you thought that was a JavaScript file, because it wasn't.
You get that working? All right, are people following along now? You got it working? So some of the stuff, I won't move on from that. Let's just talk about some of this right now to show some of the niceties that we get here, right? Is if I do this npm test again, if we compare the output from our own, like here's what Jest gives us. It gives us this nice pass message. It tells us what test pass. It tells us it ran all our test suites. That's, I mean, you know, it's a nice bit of graphical, structured, colored output of some kind, right? And if we were compare that versus what we already had in this project, which is this zip test that we can run. So if I run this node zip tests, Oh, zip is not a function. Did I break something here? I think I did, right? I changed something in here. Exports.zip, zip. Or did I change something here? Oh yeah, maybe that'll work here. I think that fixes it. There we go. If we compare those outputs, right? Ours is nowhere near as pretty as what we got from Jest already. This is a lot more cluttered, a lot more stuff going on than this NPM test output, which gives us some really nice visual cues about what's going on. So by itself, that's already a benefit, but as we go through the rest of working with this, you'll get to see a lot more of the benefit you get from leveraging a testing framework like this as opposed to doing this stuff from scratch. So next thing I was going to talk about, right, is what's going on in this code. Well, this is using a new function that exists, we get from Jest that isn't built into JavaScript itself. And that's this expects. This is sort of the language that you'll encounter a lot when you're doing this testing. So let's go back and look at the tests that we had written for the zip before, right? We had some tests that say, oh, it should be a function. And then we had one here that says should return an array. And we have expected results, and we do some logic here to check it. That's all, or a lot of that is being encapsulated in the way this test is written. So let's try and convert some of this over logically. Here's this test name. Let's go look at this. We've got a string as the first argument to this test function. That's really your test name. So it's already, oh, now the door shuts. It's already, showing us that same pattern, collapsing some of that stuff. And then we've got, here's our logic. If it's this, do this, or we expect it to look like this. Well, that's what this expect allows us to do, is we're building some stuff out. We're taking an action, and then we tell it what we expect running this to be this. So the syntax is a little different than the way we were writing it before. It involves this concept of chaining functions to be able to get some logic. As we convert the zip ones over, you'll be able to see that more clearly. But we can write, before we move into the zip ones, we can easily write a couple tests from scratch for these other math functions that we have as well to help us just make sure that all of that's working correctly, right? Which is, let's go into our math.test and let's say, well, we also want to test subtraction. What do we want to subtract? Minus 8. Want to equal 42. And I'm just going to use this lazy man's syntax that we have here for this function. Again, don't worry about that right now. We're going to go over in detail how that relates to the other functions that we've written. This is just by rote follow it right now. I'll talk about how that relates in one of our upcoming classes where we talk about all the nice new features that we get with ES6 that we'll be using. And now I can write my expect bit. And what I can say is math.subtract. Oops. And my editor is really nice and it helps me find my methods that I exported or functions I exported. So if I subtract 50 and 8, and then that's inside of expect. So outside of that full inspect, I'm going to chain this other method. I expect that to be, the result of that to be 42. And actually, for the moment, just so that I can show you a failing one as well, I'm going to come in here and screw this up. so you can see it fail. But now if I do this npm test, we'll have two tests that we're going to run. We're going to run the add one and we're going to run the subtract one. And boom, now we get a lot of more information from Jest. It tells us, oh, add 1 + 2 to equal 3. That ran in 6 milliseconds. Green check mark, that's exactly what we expected. Your test passed. But a red X on subtract 50 - 8 to equal 42, it's not what we expected. We expected 42, but we got back -42 instead. So now we're getting some really useful things that are coming out of this as well, right? Is it's not just telling us that it failed, it's telling us how it failed. It's saying, oh, I thought I was gonna get 42 and I got back -42. So that's definitely not giving us what we want. So I can go to my code. Okay, well, there must be something wrong. Oh, sure enough, I'm subtracting stuff the wrong way. I need to do A - B. Order matters in subtraction. So now if I run my tests, we get to see that everything passes as we expected. And you should notice that this language is an attempt to be sort of fluent. Maybe it doesn't read perfectly, but it's an attempt to read like a sentence. So it's an attempt to make this easy to express. Like, I expect the result of subtracting 8 from 50 to be 42, right? I expect the result of this to be 42. And so that'll help you remember when you're trying to work with this stuff, how it's intended to work. Does it make sense so far? The other thing to realize here is, I'm focusing on this expect, but we've got another new function that we're working with too, which is test. And that's how you're telling Jest, this is a test that you run. So let's add one more. Let's test multiplication. Multiply 13 times 5 to equal, I don't actually know what that is off the top of my head. 130, is that 75? Is it?
65.
65, there we go. All right, so now I can, and here's an interesting thing you can do too. Sometimes you don't know, but maybe you know that your code is correct. And this is sort of a backwards way to do something. If you're writing tests for code that's already there, and I'll talk in a minute about why you would do that. When you're doing that, sometimes you'll write a test just to have it fail so that you can see what the expected result was. So you might do something like math.multiply 13 and 5, and let's say I don't even know what it is. I'm going to be like, I expect that to be 0. And then I'm going to run my code. And it tells me, oh, 65 was the actual result. You thought 0, it failed, right? But now I can go in here and say, oh, of course I expected it to be 65, silly me. That's what I meant all along. So if this sounds weird, right? But let me give a little bit of an explanation why you would do this, because this is actually a relatively common practice when you're doing test-driven development or when you're working with existing code. So if you have existing code that you know works the way you want it to work, and yet you want to rewrite that code in some way, like, oh, I want to go refactor this code and change it, and we want to clean it up. And it's really ugly and we want to clean it up, but we don't want to risk breaking the existing code when we clean it up. We know we want it to behave the exact same way after we've changed it. We just want to rewrite it. Then what you might do is you might write these tests and say, let the result of running it be what you put in as the expected result, because you want to make sure that it does the exact same thing after you've changed the code, right? So you might write a bunch of tests with different inputs, let it tell you what the output is. Say, oh, I expected that to be the output. So you go back and put that in your test afterwards. And now what you've got is a set of tests that you know when you change your code, they're still going to pass if your code's logic didn't change. So that's the time when you would actually do that exact action, which is sort of silly, but it's a great little practice to do in the real world sometimes, where you're like, oh, I need to add tests to existing code that's not there so that I can change that code without worrying about breaking it. You feeling good with this so far? All right, so now we're gonna do the more complex one. I'm gonna go and rewrite or translate these zip tests into a different set of them using this syntax for Jest. So since it expects the file a certain way, I'm going to create a new one, zip.test.js. I'll leave my old one around for now. And again, being the properly lazy person I am, I'm going to just copy this stuff over here. I'm going to run this npm test, and it shouldn't find any new tests here. Oh, but it does say it failed. This test suite failed. But it didn't have any tests that it needed to run there. But the test suite failed, and I'm not sure exactly why it's saying that. Something happened in it that probably shouldn't have happened. So I'm going to need to probably comment all these tests out of this, and then we can maybe bring them back in, or maybe I'll just go back and forth instead and add them in one by one. So let me, I guess I'll go this route. And let's say we don't have any, and we'll go back and forth between them. So if we come over here, the first test we had was just zip function should exist. I mean, we can write this test as well. It might be a little interesting to try to figure it out exactly how I'm going to test that, but let's give this a go. Zip function should exist. Use this little notation. And let's see here. I guess I might just be able to do the same thing. I don't even know if I actually, I'm gonna check something here. This is me sort of testing. I don't know exactly what's gonna happen, but I'm gonna say, maybe if I just try and invoke this, and I'm going to make the function not exist by not like exporting it, for example. So let's see what happens if I try and run these tests now. Hey, look at that. It fails because the zip function doesn't exist because it couldn't import it, right? So I was hoping that would happen. This is me sort of testing the Jest bit, is this test runs and it fails. The test failed because there was basically an error inside of the test, is more or less what happened. But it handled that error in a sort of clean way for us. It wasn't that bad. So let's see what happens if I go back here and, right, we export it again. All right, it looks like we're passing our tests, right? Now, here's where it's gonna get, we're gonna start using some of the other capabilities that we get from Jest that will make this go a little more smoothly as we keep adding more stuff. So I'm gonna go back over to this Jest documentation and show you some other things that we can do. Let me see here. So one of the cool things that we can get from Jest is if we look at the command line options for it, like what are all the options that I can do when I'm working with Jest? Like I've got a lot of options here. And one of them that's really handy when you're writing tests or doing development actively is what's known as watch. And so watch will, as it says, it watches files for changes and reruns tests related to the changed files. So here's what I'm going to do for that. I'm going to add another script to my package JSON here, and I'm going to call it test. I don't know, test develop. Like for this is while I'm doing development, and this is just going to be Jest with this watch parameter on there. And you could do this. You could have passed that parameter into the existing one as well. This is just the type of thing that I would typically do. I would probably normally actually call this like test unit. Like I'm running unit tests and I just want them to run over and over. And now what I would do for my development is I'm going to do npm run, and now I have to say run because it only knows about a few special phrases in there. Test unit. And now we've got Jest here running, and it's in this watch mode, and it even gives us some special commands here. Press A to run all tests, press F to run only failed tests, press P to filter. So now we've got a lot of interesting options, and Jest is giving us sort of a continual output here. So I'm gonna show that a little bit. I add another test here. What was, say, the next one? Zip should return an array. All right. My semicolon here. Test this guy out. So I know I want to run zip. So I'm just gonna store the result of running it somewhere. If we go back here and look at this, this is going to look a lot like what we're doing here. Oh, well, here's checking for this. This will give us a true value or a false value, right? So I'm basically going to translate that. Over here, and I'll say I expect array.isArray of, in this case, I just called it result. I expect this, which is checking, is this an array, to be true. And what was really cool there is I didn't have to do anything because I'm watching those files with Jest, and it automatically reran those tests and it passed it right away saying, oh yeah, you're already doing that. Good to go, right? So now we're getting into some of the really useful mechanisms that we get from being able to leverage a test library like this. This is that cycle of you just leave these tests running while you're doing development, and then you immediately know if you broke something. So, oh, I'm working on something. Oh, I've got some tests already around it. I want to do some refactoring. As I'm refactoring, I save it. Oh, I broke something. I didn't think about that behavior, right? So this is some really, really useful capabilities that we can get working this way. So let's see what our next one is here. Should return a single array containing each item for 2 single item arrays. Oh, like A and B. Okay. That's a long statement, and I'm a properly lazy person. So I'm going to copy and paste it instead of writing it out. Test, boom, oops, semicolon, this arrow function, syntax. And then what do I need here? Let's go look. It called it with zip A and B. We'll do the same thing here. Var result equals zip A and B. And I expect result to be A and B, right? Let's see what happens. We failed. Any idea why we failed?
serializes to the same string, so instead of it being an array, just get a string of AB. Is that what it means?
Well, that close. You're getting there, and I mean, I don't expect somebody to necessarily understand this. Let me ask you. Here, let's go back to talking about the way some of these objects work, or let's pull up another terminal window real fast, and we'll just do some node stuff right there. Is if I say var foo equals A and B, and I say var bar equals A and B. What's the result if I do foo is equal to bar? They're not the same. Do you remember why? It's because they're actually pointing at two different array objects. It's not checking if the values are the same in the array. It's checking if it's the same array object. So now if I made another one, I said var foo bar equals foo. If I look at foo bar, I have AB. If I look at foo, I have AB. If I look at bar, I have AB. But foo equals foo bar is going to be true because they're actually pointing at the same object. And to reiterate that, if I did foo.push C, now if I look at foo or foo bar, they have that, but bar doesn't have C added to it because they're actually two different objects. They just have the same values in them, right? So this stuff, this is gonna, you're going to get used to this, but this is the type of stuff you'll internalize working with stuff over and over, right? So now if we go back and we'll look at our test that's running, oh, it does serialize to the same string, but it's not the same object, and that's what it was checking. Okay, well then maybe Jest can give me some tool to help out with this. Let's see. What are my, I'm gonna go over here and look at expect. There's a whole bunch of methods on here. I can expect anything. I can expect certain stuff. I can expect to not be a string containing, not an array containing something, not an object, to not be something, to be something. Okay, let's click on that because that's what we're doing. Use 2b to compare primitive values or to check referential identity of object instances. It calls object.is to compare values, which is even better for testing than triple equals strict quality comparison. Don't use 2b with floating point numbers. Here's why it tells you that they serialize to the same, because it says, although 2b matches checker's referential identity, it reports a deep comparison of values if the assertion fails. That's why it's giving us that extra bit of message where it's like, hey, they did serialize to be the same. Okay, so 2b is not what I want, which now makes me, I mean, look, if it was me not knowing, I'd have to be digging all over the place. I really wish that they had a note here that says what to use instead of 2b if you want to do that. But I'm pretty sure that the answer is, I should be able to scroll down here a little bit. Let me see. To equal. Use to equal to compare recursively all properties of object instances, also known as deep equality. For example, 2 equal and 2b behave differently in this test suite, so all the tests pass. So it's giving me a little bit of a, to equal will check the actual values as opposed to checking if they're the same object. So let's try that. I expect it to equal this. And we pass, because now it's actually checking all of the items in that array to make sure that they're the same. Right? And again, we go back up here. Obviously, people have a need for a lot of different stuff. There's a lot of different tools we can use for testing. Remember when I did that to be true before? Instead of to be true, I could have done a to be truthy. So we can go back up here to this to be true and convert this to say to be truthy. And it should pass because it's saying, oh, I expect this to be truthy. But there might even be one that checks like against an array. I don't know everything that is here. So here's array containing. Matches a received array which contains all of the elements in the expected array. Oh, so maybe even this two equals, maybe we can even change this. Let's see. Now we've made it more explicit, potentially. No, it doesn't work. So I don't know exactly what I'm doing with that because I haven't used it before. Oh, it says it's not a function. So I did something wrong here. Let me look at the syntax for it. Oh, I need to do it a little different. I expect it to equal an array containing some stuff. Okay, the syntax is a little different than I expected. So I'm just going to go back to what we had. This is to equal for now because it's nice and easy. But yeah, it's got a lot of useful tools here to check against different properties, right? So let's continue with this. And it looks like I can probably drop this down while they're passing at least. What's our next one? Zip should return a single array containing each item. I missed a word here. Each item in equal length arrays. All right. And we passed in A, C, and B, D. So we'll write this test. Let me put my semicolon. Var result equals zip. I could put this result line directly on the same. Actually, because I want this to be what I already have, I'm not even going to rewrite it because I want it to match exactly this. So it's safer for me to copy that code so that I know that it'll match. Like I could inline this into the expect, but I tend to like putting it on a separate line so that that inspect reads a little more concisely and you don't have as much in one line of code. So now I have this expected result. Oh, look, I was using join to sort of put stuff together here for this. But we can just put them in here. Result dot to equal. Let me double check this code here. Yeah, this is me still being able to use that sort of lazy syntax. And if I want to make that on a separate line so that again it reads cleaner, I can put it up here. Var expected equals this string joined together. And then I can say I expect result to equal expected. And hopefully that works. Nope, have something wrong. I can't just call join like that, so let me double check. Oh, I was doing it the other way around. I wasn't converting this into an array. Okay, let me flip this instead. I'm going to change the way that I do this. This isn't join. I want to split. I want these to be arrays, and I'm going to split on that. So that's me just flip. That's me knowing that those exist on arrays and strings. So the logic in here, what I was doing in the zip tests was I was taking the array output of zip and converting it into a string with a comma separating each item from the original array. But I decided now in this new stuff that I prefer taking this string and converting it into an array. And so instead of doing a join on the array, I'm doing a split on the string based off the commas, which gives me back an array of those items. And the only reason I'm doing that is because I'm lazy. And as these get longer, like right now it's not bad, but as that gets longer, it's going to be much shorter to type out a string and do this split than it is to type out all of the items in the array. That's really the only reason I'm doing it that way, is for a little bit of simplicity in my stuff going forward. Any questions on this? Making sense? So this is, again, this is what we will be using when we get into the React stuff. And I'll just highlight a few other things after we finish this. This basic conversion of these zip ones that we're going to be able to leverage, but some of that we can't use yet. But I'll highlight a few of the really powerful things that Jest will also give us. So what's our next one that we have? We had when the first array is longer than the second array, return all the items from the second array, move this one over. So this is our test, because this is going to get really long. And you really probably shouldn't have names quite this long. But I wanted them to be very descriptive. And the correct zipped array, it contains all elements from the second array. So now here, again, I'll have var result equals, stealing my bit of logic here. And then this did the same thing. I've got this 42 and 13. So I'm going to put that in expected equals that dot split on a comma. And I can say expect result dot to be, or to equal, see, expected. I almost made the mistake again. Although the first time I did it, it wasn't a mistake. Okay, I must have something wrong here. Let's check. It says, I expected an array of 42 and 13, but I received an array of 42 and 13. I received an array of numbers as opposed to strings, and I did want them to keep the same type. So that's why the split here wouldn't work. So I guess I do need to do it the other way around in this case, or I need to convert these to numbers, right? Because I do want them to be numbers, not just strings. So maybe I will do it the other way around. I will say, or maybe that doesn't work because the 42 and 13 could be, you see, I just sort of found what could be a bug. I could have a bug in zip that I wouldn't have caught with my old tests because I was doing a string comparison. I was converting my array into a string with a join, which means that it could have been string versions or array versions of what I had. So here, I'm going to write them out explicitly. That's my expected results. And I'm actually going to even capture this because I just realized I sort of missed the test, something that mattered. And I'm going to capture this as a test that's going to test something just a little different. Oops, too much white space. That says, zipped array items should be same type as input arrays, right? And actually, that's a pretty complicated test to write. So right now it's like, oh, I know I want this test, but I don't have it. But I know I want it in there. That's gonna be a little bit of a challenge to get correct. Maybe, let me see what exists here. Oh, I'm looking at this test each, test. What is this skip thing? When you sometimes find a test that is temporarily broken. Oh, you know what I'm gonna do? It's not temporarily broken, but let's say I don't know how to write this test yet, but I know I want it to be a test at some point. So I wrote this extra test here, and it will tell me we skipped a test. So it didn't actually run this test, but it's sort of a placeholder saying, oh, I know I'm gonna want that test. Now you might do that, again, their point is like on a large code base, you may have a test that's broken because, I don't know, you're refactoring and it's broken right now and you're like, I need to skip those because I know they're gonna be broken until I fix this other portion of the code. We're using it for a different reason, but. All right, what else do we have here? Oh man, we got a lot more tests. So let's grab this one. Rewrite this test. Is when the first array is shorter than the second array. We're going to return the correct items. If I want to make sure I have the types right, I can't be quite as lazy as I wanted to be. I'm going to have to write this out a little more explicitly, which it looks like the result should be an array with hello, 3, world, and 5. So I'm just going to write them out explicitly. Now, if I was doing a lot of these, I would do some sort of utility to make this easier to do instead of writing them all out, maybe. But now I can say expect result to equal expected. You'll notice by putting these things into variables in each one of these tests, for all of these at least, my expect line has actually been exactly the same. And part of the reason I did it that way was to help emphasize that you're really doing the same type of thing. It's just figuring out when you're writing them this way, what the result is and what the expected is that you're trying to figure out. And those can vary, but this is sort of that same pattern that you're repeating over and over. What else do we have? Now we get to an interesting one. Throws an error when the first parameter is not an array. So we want to throw an error. Oh, the way we did it here was this sort of try catch. All right, well, maybe we can, gonna move this over. Let's see. I want to indent all this. So I sort of want to, I don't even know if that's going to work. Let's see if this gives us a tool for this again. What do we have here? Expect, rejects, resolves. Let me, to throw. All right, let's see. Use to throw to test that a function throws when it is called. For example, if we want to test that drink flavor octopus throws because octopus flavor is too disgusting to drink, we could write expect, and then you must wrap the code in a function, otherwise the error will not be caught and the assertion will fail. Okay, so it gives us a little bit of a hint here saying you need to wrap, we need something like this. So because they give me some help here, I'm going to leverage that. Except I know that I don't want to call drink flavor. The thing I want to throw in error is this operation. So I'm going to put that up here. And let's see if that works. All right. Now, one rule, I'm sort of skipping over this, which is very dangerous. One thing that's very, very important to do when you're writing tests like this is to make sure that your test does fail. So really, I should go in here and do something like get rid of this to make sure that this test that throws an error will fail if my code does not throw an error. Because it's very possible for you to write a test that accidentally, I've got tests that do this, accidentally asserts that true equals true because you never verified that it fails. Because you can write a whole bunch of complex code that ultimately just checks that true is true. And then your test will always pass because true is true. And you're not actually testing what you think you're testing. So making it fail helps ensure that you're testing what you think you're trying to test. We'd be even more specific here, right? Let's go back and look at this. It had an extra parameter. It has a parameter to throw. So we could test that the error message says something within it, is what it looks like. Or we could test an explicit error message, which is what we wanted to do before. Because in here we were testing that we wanted it to be a type error. So if I go back and look at the documentation, I can say test that I expect it to be this type of error. Oops. So let me put that in there, right? And it should pass. But I'm going to make it not instead here. So let's again change this code and throw just a general error. Now, hopefully it should fail because we didn't get the expected type of error, right? It threw an error, but not what we wanted. Now we can make our code go back. And this, again, that really nice aspect of watching is I can do this without having to do any extra work. It's just telling me right there what's going on. Do we have any other ones? Throws an error when the second parameter is not an array. So that one's pretty easy. We've already got all of the logic. So I'm literally, I'm going to cut and paste here. We're going to change just one or two things. We're going to flip these around. Right, and we know we're passing, and we could that's not going to work. All right. We could test that will fail by getting rid of the condition for the second parameter in our code. And then do we have any more? I think that's it. So now we've translated all of the tests that we had over here into Jest tests, which frankly read a lot more nicely, are a lot more self-contained, to me at least. You get much nicer output, and you get a ton of tools to help you test different aspects of your code very easily. What do you guys think of this? Does it seem like it's a more useful way to do that sort of testing? Yeah? Not sure? Like, I haven't written enough tests, I don't know. So now let's talk a little bit about some of the other benefits, and I can just, I can stop the the Jest test from running. Some of the other things we get with Jest, right? So I'm going to go back to this, where's my CLI options? And we have all of these options over here, which are, you know, some of them maybe you don't really need, but some of them, again, are really, really useful. So we looked at this watch, and then you can even change some settings around that. But I don't know if this is going to work the way I want because I haven't tried it on this at all. But let me see if this works. Another one that's very common when you're doing testing is what's known as code coverage. And code coverage is the idea of saying how much of my code has a test that executes it. So let's say you've written 100 lines of code in a file, but your tests only execute one little portion of that code when you run tests. Then it'll say, oh, your code only has this much code coverage from your tests. You're not running all of your code. You're not testing it all in some way, right? And Jest has a nice built-in mechanism for capturing this stuff for us. So I'm going to just go back to this npm test. I can pass extra parameters in to the underlying thing being called by doing this dash dash. And now what we'll see is it gives us information about the files in here and what their coverage is. It says the math.js file, 100% of the statements are tested, 100% of the branches, 100% of the functions, 100% of the lines, and same for zip. And you notice it doesn't check anything about any of the other files in here. And that's because it's only looking at files that in some way or another get required or imported. It doesn't scan for any files that exist. So let's change these numbers a little bit. And let's get rid of the tests on subtract and multiply. And run the same thing. And now what we see is for the math.js, only 50% of our statements are covered in some way. And only 33% of our functions are tested. And it even tells you nicely, like, ooh, line 6, this subtract line, and line 10, the multiply, like these are uncovered. You have no tests for that. So this is some of the stuff that you start getting when you are leveraging a library like Jest. And then it also has, and this gets into stuff that's going to be really useful when we start writing React, is when you're testing UI, it can be really, really hard to test a UI without having to write really complex code or without your test just breaking randomly because, oh, I changed my UI a little bit. I moved my button over a little bit, or it shifted over this way because of some minor CSS changes, and my tests failed because it was just looking at this whole UI and trying to click something, right? And Jest gives a really useful tool that we'll be able to use when we get into React testing for that stuff, which is known as snapshot testing, where basically it will render, and I don't know if it totally renders the whole UI or just the React components, but it'll render what's like its own snapshot of it. So you can imagine also, like, our tests are pretty simple right now because we're just doing like an array. But if you have a very, very complex object, like an object that's nested, I mean, it doesn't even have to get that bad. Imagine trying to write tests that check if this package JSON is correct, right? Like, that's gonna be a pain in the butt to try and make sure that, oh, I wrote all of this out in my test. And, oh, if I change my syntax a little bit, I have to go change all of my tests to make sure that they've got the correct expected syntax for that. Our tiny arrays aren't that big of a deal compared to something like this, right? Snapshot testing, sometimes it's controversial by some people. I think it's really, really useful. What it'll do is, going back to that idea that I just talked about earlier where I said, oh, I don't know what the right return value is for 13 times 5. So I'm going to let it compute it, and then I'm going to put that in as the correct value. Snapshot testing is more or less a formalization of that, where if you have certain things that you want to test in a way like that, you can say, okay, well, what I want you to do is run the test, and as long as you don't already have a snapshot of what the result should be, take the result that you get and save that as the correct result going forward. And then the next time you run the test, if my result doesn't match the correct one that I saved, then let me know and fail the test and give me the option of saying, oh no, I changed it. This is what I want it to be now. Versus, oh shoot, I didn't intend to break that. And then, there's just layers and layers of complexity of things that Jest can tie into in the ecosystem. So you can test inside of browsers. You can test backend stuff. We'll get into mocking stuff in different ways when we're doing some of our testing that we're going to need to do. But there's just tons and tons of capabilities and tools that exist inside of this Jest framework that can help you out when you're writing these tests. You can change the colors if you want them to look different in your output. Yeah, I mean, this is really what I wanted to make sure that we talked about today, is starting to introduce this other new tool for testing. Are there any questions about this so far? So again, one thing I would suggest to continue building on things as an exercise is if you have already started working whether you finished it or haven't finished it, if you've been working on the correct change program, what I would suggest is try and pull in Jest and write tests in a separate file for your correct change program based off different values of change, right? Oh, if it's under 5 cent difference, do I get the pennies I expect? If it's this different, much different, do I get what I expect, right? Try and write tests for the different types of output that you would expect there. That'll give you practice on using a testing framework like this. It'll give you practice on writing tests against your code and sort of working with that model. All right. If you don't have something else, I'll give a preview. So what we have left coming up is we'll do a little bit more stuff integrating in like a web page going forward with our stuff. But the big topics that we still are going to cover in this sort of intermediate course are mostly newer JavaScript concepts and syntax, which is going to be a lot of the ES6 syntax, which for the most part is just syntactic sugar on top of existing JavaScript, which just means it's a way to write things a little more easily. There are a few of them that aren't really syntactic sugar that are actually meaningfully different elements of JavaScript, but most of it is just ways to write things a little more simply than we're used to writing them. But that's really what the major stuff we'll be covering. And then, as I said, a little bit more tying into the browser and talking about how you work with JavaScript connected to a website. And I know people have been doing, I have not been keeping up with what everyone's working on in the HTML, CSS course. So somebody who's been actively participating in that wants to spend a little bit of time talking me through what you've been working on, because we might be able to use one of those as an example or a starting point for doing some JavaScript browser integration. That way, it's not something completely foreign to you. That'd be awesome if you've got time today, or if you want to hit me up after class or something and say like, oh, here's what we've been working on. Here are the projects that we've done. And here's, my examples of them. That way I could maybe build like the web examples off of that, so that anyone who's been working in that course would at least already be comfortable with that portion of it. I think that's all I had today, so it's a little shorter. Unless there's another topic anybody has questions about and wants me to go over again. All right, then we'll get done a little early today. See everyone remote on Tuesday, but in person again on Thursday. And I appreciate seeing a lot of faces in here today. It's nice to see people actually here. I did want to on Thursday, I was hoping to do more of a hands-on group exercise with some stuff, but it's a little hard to do that when there aren't a lot of people here as well. So we might try that again either this next Thursday or Saturday, depending on how many people show up, is sort of that group hands-on exercise where you're working on something together. All right, talk to you guys later.